June 6, 1944. Normandy. Morning fog clings to the jagged coastline. The distant roar of naval guns shakes the cliffs. German bunkers rise like stone sentinels, their concrete faces scarred by years of preparation, lined with steel embrasures and machine guns. Every hedge and crater seems alive with hidden eyes. Through the mist, a column of U.S. Sherman tanks emerges, engines growling, treads crushing the soft earth. Soldiers crouch behind them, gripping rifles, scanning for movement. The Germans wait, confident. Their bunkers were built to repel any armored assault. Tanks would crumble against their steel and concrete. Then it happens. One Sherman climbs an obstacle, a jagged anti-tank wall, as if the rules of gravity had been rewritten. Another follows, tracks grinding over sandbags, steel teeth biting into earth. German soldiers freeze, disbelief in their eyes. How could a machine defy the fortress meant to contain it? Every tank that climbs, every obstacle overcome, sends a ripple of fear through the defenders. The impossible becomes visible, and for a moment, the battlefield itself seems to bend to the Americans' will. This was more than a maneuver. It was a revelation. By mid-1943, the war in Europe had reached a crucial stage. The Allies were preparing for a full-scale invasion of German-occupied Western Europe, a campaign that would test not only manpower, but the limits of engineering and armored warfare. The Atlantic Wall, Hitler's vision of an impenetrable coastal defense, stretched from Norway to the Spanish border. A complex network of bunkers, artillery emplacements, minefields, and obstacles designed to turn any assault into slaughter. Every inch of these fortifications had been meticulously planned, constructed and manned by German engineers and soldiers who believed in the invincibility of concrete and steel. The German doctrine of defense relied heavily on interlocking fire zones. Each bunker covered its neighbor. Machine guns swept every field of approach, and artillery prepared to engage targets at long range. Anti-tank ditches and wooden obstacles, Czech hedgehogs, steel rails, concrete tetrahedrons, were designed to immobilize armored units before they could breach the inner defenses. The Germans had fought tanks before. From Poland to France, their experience with panzer divisions convinced them that tanks could be neutralized with prepared obstacles, precise artillery, and coordinated infantry. Fortifications were meant to exploit these weaknesses, making it nearly impossible for Allied armor to advance without catastrophic losses. Across the Channel, American engineers studied these defenses with painstaking care. The lessons of North Africa, Sicily, and Italy had been brutal. In every campaign, obstacles had slowed advances, mines had destroyed vehicles, and heavily fortified positions had required costly infantry. Assaults. U.S. Army planners knew that the success of the upcoming invasion would depend not only on sheer numbers and firepower, but on technological ingenuity. Sherman tanks, versatile, mass-produced, and relatively reliable, would form the backbone of armored divisions, but they would face challenges that exceeded anything seen in the Mediterranean theater. German bunkers were stronger, obstacles more sophisticated, and terrain less forgiving. Innovation became a necessity. The U.S. Army's Corps of Engineers developed specialized modifications for the Sherman and other vehicles. Bulldozer blades were mounted on tanks to clear debris and fill trenches. Some were equipped with flails to detonate mines safely. Armor was reinforced to withstand artillery bursts and small arms fire at close range. Engineers experimented with ramps, fascines, bundles of wood to fill ditches, and bridges that could be deployed in seconds. The aim was simple: give armored units the ability to overcome obstacles without halting under enemy fire. Meanwhile, German forces were confident in the enduring superiority of their defensive architecture. Veteran commanders had seen previous Allied assaults fail against fortified positions. Concrete bunkers, often 2 meters thick, were paired with long-range artillery and strategically placed machine gun nests. Every coastal village, every dune, and every cliff had been mapped and fortified. Soldiers manned these positions, trained to repel assaults from both infantry and tanks. The Atlantic Wall, in their minds, was invincible, a statement of German engineering, discipline, and tactical foresight. But the Germans underestimated one critical factor: American adaptability. U.S. tank crews were trained not only to engage enemy armor, but to think creatively on the battlefield. They practiced overcoming obstacles, coordinating with engineers and infantry, and using terrain to their advantage. Lessons from previous campaigns had honed their ability to improvise, to use speed and momentum to bypass threats that seemed insurmountable. Sherman tanks, often criticized for thin armor compared to heavier German panzers, had one advantage: they were highly maneuverable, mechanically reliable, and could be modified for specific tasks. When paired with skilled crews and coordinated support, these machines were capable of feats that defied expectations. By the spring of 1944, these preparations converged into a carefully orchestrated plan. The Allies amassed tens of thousands of troops, vehicles, and supplies along the southern coast of England. Every Sherman tank was inspected, modified, and tested. Engineers rehearsed obstacle-clearing techniques on mock bunkers and coastal fortifications. Soldiers drilled with combined arms tactics, integrating artillery, infantry, and armor to create a synchronized assault capable of penetrating the Atlantic Wall. The Germans, meanwhile, relied on intelligence reports, aerial reconnaissance, and entrenched confidence in their fortifications, but few anticipated the extent of American innovation and mechanical ingenuity. The stage was set for a confrontation, not only of armies but of engineering philosophies. German bunkers represented permanence, immobility, and brute resistance. American tanks embodied adaptability, speed, and mechanical ingenuity. The contrast was stark. One side trusted stone and steel to dominate the battlefield. The other trusted wheels, treads, and human ingenuity to rewrite the rules of engagement. And when the first Shermans rolled across Normandy's beaches, the reality of this clash would shock German soldiers, redefining the relationship between armor and fortification forever. June 6, 1944, D-Day. Dawn broke over the beaches of Normandy, with a gray light that barely revealed the chaos below. Overhead, thousands of Allied aircraft droned across the channel, dropping paratroopers behind enemy lines, while naval vessels pounded German coastal positions with relentless artillery fire. On the ground, American infantry advanced through surf and sand, facing machine gun nests, barbed wire, and mines. Yet the real test was not only the beach, but the bunkers, concrete fortresses designed to halt the advance of any mechanized assault. The German defenders, seasoned and battle-hardened, waited in their pillboxes. Many had fought in France before, in 1940, and had seen how tanks could be neutralized by well-placed anti-tank obstacles and overlapping fields of fire. They manned their positions with confidence, believing their engineering expertise had created an unbreachable line. Coastal batteries bristled with artillery, mortars, and automatic weapons. Every inch of terrain was designed to maximize killing potential, forcing attackers into narrow kill zones. From their perspective, the Shermans approaching the beach were just another wave to be destroyed. But American tanks were not approaching like their predecessors. Sherman crews had trained for months in obstacle-clearing techniques, coordinating closely with engineers and infantry. The modifications made in England, bulldozer blades, tracks reinforced for rough terrain, mine flails, were not experiments. They were battlefield-tested solutions. Tanks moved in coordinated columns, each unit assigned specific objectives: suppress machine gun nests, clear obstacles, and breach bunkers. Engineers rode alongside, ready to deploy fascines or ramps wherever trenches or anti-tank ditches threatened to stop progress. The first encounters were shocking to German observers. Shermans mounted with ramps approached pillboxes directly. Crews aimed and fired, using high-explosive shells to neutralize enemy gunners. When faced with deep ditches or anti-tank obstacles, tanks used momentum to climb over, literally rolling onto the roofs of fortifications in some cases. The combination of speed, firepower, and engineering ingenuity seemed impossible to the defenders. What they expected to be immovable concrete proved vulnerable, not through brute force alone, but through careful planning and mechanical adaptation. German officers sent frantic reports to command. Intelligence noted that tanks were not stopping at previously impregnable positions. Pillboxes that should have held entire regiments of attackers were bypassed or overwhelmed. For the first time, experienced commanders saw that fortifications, no matter how well designed, could not account for the creativity and adaptability of Allied armored units. Tanks climbing bunkers, crossing ditches, and neutralizing heavy machine gun positions in minutes defied their understanding of conventional warfare. Their doctrine, built on centuries of siege tactics, was being rewritten in real time. This was not limited to Normandy. Reports from Italian campaigns, Sicily, and earlier Pacific engagements had already demonstrated the effectiveness of specialized armored engineering. But Normandy represented the largest-scale confrontation of fixed fortifications and mobile armor. The Germans had prepared for a massive amphibious assault, yet they had underestimated the integration of tanks, engineers, artillery, and infantry. The Sherman tank, once criticized for light armor and moderate firepower, proved ideal for the task. Reliable, modifiable, and capable of sustained operations under intense fire. The combination of design and ingenuity allowed American units to accomplish what seemed physically impossible: dominate terrain that was meant to be untouchable. Meanwhile, Allied planners were monitoring progress carefully. Commanders recognized that these early successes validated months of preparation. Engineers, who had trained for every conceivable scenario, were seeing their solutions executed flawlessly in combat. Infantry units could advance more quickly, casualties were reduced, and German defensive coordination began to falter. The psychological impact was significant. Defenders who believed in the immutability of the Atlantic Wall were suddenly facing a foe that seemed unstoppable. Every bunker climbed, every trench crossed, and every machine gun silenced reinforced the growing impression that traditional fortifications no longer guaranteed victory. By midday, the scale of the transformation became apparent. German defensive lines, designed to last for weeks or months, were being broken in hours. Sherman tanks, equipped and crewed for ingenuity, dominated the battlefield in ways the Axis engineers had never anticipated. Commanders witnessed armored vehicles surmount obstacles, destroy bunkers, and maintain a rhythm of advance that combined firepower, momentum, and mechanical cleverness. The Atlantic Wall was no longer an unyielding fortress. It was a challenge to be overcome, and the Americans had already found the solution. The stage was now set for the angles of this story: the human courage of tank crews, the technological innovations of armored warfare, and the tactical evolution that would redefine how fortified positions were approached. What began as a confrontation between concrete and steel had become a testament to adaptability, preparation, and the relentless drive to overcome any obstacle. The first Sherman crews to breach the Normandy beaches faced conditions that would test any soldier's resolve. Standing in the open cockpits, gunners scanned for enemy positions while machine gunners lay prone atop the hull, exposed to artillery and sniper fire. Waves of bullets and shrapnel tore through sandbags and timber obstacles, yet tankers pressed forward. The courage required was both physical and psychological. Crews relied on trust, not just in each other, but in their machines. Every climb over a bunker or anti-tank ditch demanded split-second decisions: adjust speed, angle the tracks, or fire shells to soften resistance. For many, fear was constant, yet professionalism and training created a calm that contrasted sharply with the chaos around them. The Sherman tank was not invincible, but it was adaptable. By 1944, modifications had transformed the standard medium tank into a battlefield Swiss Army knife. Bulldozer blades allowed vehicles to push aside obstacles, while angled armor and reinforced tracks improved survivability. Engineers fitted tanks with portable ramps, enabling them to scale low bunkers or cross anti-tank ditches previously considered impassable. Flail tanks cleared minefields, turning previously deadly zones into open routes. Every modification was a solution to a known tactical problem. German officers observing from pillboxes were astonished. They had planned for tanks to be slowed, trapped, or destroyed, but American ingenuity created machines that could literally climb over the defenses meant to halt them. The Americans had learned from past campaigns that no single force could break fortified lines alone. Tanks, infantry, engineers, and artillery moved in precise coordination. Infantry covered exposed flanks, while Sherman crews neutralized machine gun nests. Engineers deployed fascines and ramps to cross ditches. Artillery suppressed stronger positions ahead of armored advance. This integration allowed the Americans to exploit weaknesses quickly. German commanders found that even when individual bunkers held, the continuous advance of combined forces created cumulative pressure, collapsing entire defensive sectors. The methodical pace of attack, supported by logistics and communication, created an illusion of invincibility that unnerved defenders. Command decisions shaped the battlefield long before the first shell hit a bunker. American planners studied German fortifications for months, running simulations and training crews in obstacle-clearing maneuvers. Leaders emphasized initiative at the small unit level, allowing tank commanders to make rapid decisions when facing unexpected obstacles. This decentralized command structure contrasted sharply with German doctrine, which relied on rigid defensive plans. The combination of foresight, training, and delegated authority turned preparation into battlefield dominance. Officers understood that success depended not only on machinery, but on the judgment and adaptability of those operating it. German soldiers and officers watching Sherman tanks ascend. Their bunkers experienced disbelief that bordered on panic. Fortifications designed to channel, trap, and destroy armored vehicles were suddenly irrelevant. Reports from the front lines describe soldiers lowering rifles, mouths open, as tanks seemingly climbed over obstacles that should have slowed them. The psychological impact was profound. German artillery crews hesitated, calculating trajectories for defenses that were already being bypassed. Commanders struggled to adapt, realizing that their knowledge of terrain and fortifications offered no guarantee. The unexpected mobility of American armor created uncertainty, undermining morale and disrupting unit cohesion. While Sherman crews advanced with remarkable effectiveness, the cost was tangible. Tanks were vulnerable to mines, artillery, and concentrated anti-tank fire. Every climb over a bunker or breach through a fortified line exposed crews to life-threatening danger. Yet the human spirit persisted. Letters and diaries from tankers describe a mix of adrenaline, fear, and determination. Many relied on camaraderie and precise training to survive. The combination of mechanical innovation and human endurance illustrates that technology alone did not secure victory. It required people willing to risk everything to exploit it. The ability of U.S. tanks to overcome German bunkers had direct strategic implications. Normandy's defensive network, the Atlantic Wall, was designed to delay and attrit any Allied landing force. Every Sherman that climbed a bunker reduced the wall's effectiveness, forcing German units to withdraw or face encirclement. Engineers, planners, and commanders recognized that mobility could turn static defenses into liabilities. Success in one sector enabled follow-on operations, allowing airborne troops, infantry, and artillery to exploit gaps. In effect, the Sherman's mobility turned the Atlantic Wall from a solid barrier into a series of isolated, vulnerable points. Beyond physical destruction, the sight of tanks surmounting bunkers became a weapon in itself. German soldiers reported that observing Shermans climb obstacles created hesitation and fear before engagement. The unpredictability of American armor made defensive planning fraught with anxiety. Officers noted that even experienced troops questioned whether their positions could hold. This psychological edge amplified the material advantage of the tanks, creating momentum that reinforced operational success. Commanders increasingly feared that no static position could stop the advancing Americans. The Sherman's modifications were not isolated innovations, but part of a broader pattern of adaptive engineering. Field reports show that crews could swap equipment, repair damaged tracks, and repurpose tools to overcome unexpected terrain. This flexibility allowed American forces to respond instantly to battlefield realities. German observers noted the contrast with their own tanks, often limited by fixed specifications and rigid doctrines. The lesson was clear. Adaptability in design and use could trump raw firepower or armor thickness. June 6, 1944. Normandy, France. The first light of dawn breaks over the beaches of Omaha and Utah. Waves crash against the shore, carrying the sounds of engines, gunfire, and shouted commands. American infantrymen wade through cold, surf-laden waters, each step a battle against both the tide and entrenched German defenses. Mortar rounds explode in the sand. Artillery shells whistle overhead. Every bunker, every pillbox, every obstacle is a potential death trap. Amid this chaos, the Sherman tanks appear. M4 Shermans, rolling from landing craft, their tracks chewing through sand, mud, and the tangled remnants of German anti-tank obstacles. Engineers had calculated the impossible. They could navigate the craters, cross the rubble, and even ascend bunkers that were designed to resist the heaviest armored vehicles. At Omaha Beach, near Dog Green sector, German observers record the first sightings. Tanks climb over log barriers, sandbags, and concrete bunkers, moving forward with unrelenting determination. The noise of engines is deafening, a mechanical roar that drowns out the panic and confusion among the defenders. For the Germans, it seems surreal. The Atlantic Wall, built over years with painstaking labor, is being systematically bypassed by machines designed for mobility, not destruction. The key lies in preparation and ingenuity. Engineers and designers had incorporated features to increase Sherman's survivability and traction. Wide tracks distributed weight evenly, reducing the risk of bogging down on sand or rubble. Suspension systems absorbed shocks from debris, allowing tanks to maintain momentum over jagged obstacles. Crews had been trained rigorously, practicing maneuvers in mock fortifications along the U.S. coast. Every climb over a bunker was the result of months of testing and coordination, not luck. By mid-morning, Shermans are consolidating positions inland. German machine gun nests that had pinned down infantry are suddenly flanked. Defensive lines collapse as tanks breach secondary fortifications, forcing retreat or surrender. Observers in German command bunkers write with incredulity, "The enemy climbs where no man or machine should. Our concrete walls are irrelevant." The realization spreads quickly. Tactical plans based on static defense are failing. The Allies are not merely landing, they are reshaping the battlefield in real time. At the Pointe du Hoc sector, U.S. Army Rangers scale cliffs under fire. Behind them, tanks maneuver across uneven terrain to support infantry positions. Bunkers meant to dominate the high ground are neutralized by Shermans that roll up their flanks and over earthen mounds. German artillery struggles to target moving vehicles that defy conventional lines of fire. The coordination between infantry, armor, and engineers creates a synergy that overwhelms defenses. Meanwhile, across the Omaha beachhead, Sherman crews face their own challenges. Mines, shell craters, and anti-tank guns are omnipresent. Yet, their training and mechanical advantages allow them to overcome hazards. Tracks are replaced on the fly, turrets adjusted to maintain continuous fire, and tanks operate in synchronized waves to suppress defensive positions. Every bunker climbed or bypassed signals a shift in momentum, an undeniable turning point. By late afternoon, German command realizes that the landing has achieved something unanticipated. Static fortifications, the centerpiece of their defensive doctrine, are no longer obstacles but stepping stones for the Allies. Communication lines are disrupted, reinforcements delayed, and morale plummets. Reports to field commanders describe a battlefield transformed by American armor, noting the unprecedented ability of tanks to navigate and neutralize positions previously considered impregnable. The Shermans' success is not just mechanical, it is psychological, tactical, and symbolic. The German military ethos, built on disciplined planning and fortified positions, is confronted by a combination of innovation, adaptability, and raw determination. By the end of D-Day, the stage is set. The Atlantic Wall has been breached, and the momentum of the Allied advance is secured. The decisive factor is not just the landing itself, but the ability of American tanks to overcome obstacles that were thought insurmountable. The implications are immediate. Commanders realize that the war of attrition they had planned for is now complicated by a mobile, flexible, and highly coordinated opponent. Every bunker climbed, every fortification bypassed, signals a fundamental change in the dynamics of the battlefield. The Allies are not merely fighting for ground, they are rewriting the rules of engagement. The stage is set for the inland push. As infantry moves forward, tanks continue their advance, creating corridors through which artillery, supply lines, and reinforcements flow. German positions crumble under combined arms assault. The battlefield, once dominated by static fortifications, becomes fluid, dynamic, and unpredictable. This moment marks a turning point, not only in Normandy, but in the broader context of the war in Western Europe. The Allies demonstrate that innovation, coordination, and tactical flexibility can neutralize even the most formidable defenses. The Sherman tanks, in climbing bunkers and surmounting obstacles, embody this principle. Mobility and adaptability can defeat brute strength and static planning. The next phase of the Normandy campaign will test whether this advantage can be sustained. But in these first crucial hours, one truth is undeniable. American armor has rewritten the expectations of what is possible on the battlefield. July 18, 1944. Saint-Lô, France. The town has become a focal point for the American push through Normandy. Rubble lines the streets, and every building is a potential fortress. German defenders, exhausted from weeks of bombardment and retreat, dig in wherever possible. The Allies face a labyrinth of obstacles: collapsed bridges, mined roads, fortified buildings. Into this chaos roll the Sherman tanks. By now, crews have refined their tactics. Infantry moves ahead to mark safe lanes, engineers clear mines, and tanks advance methodically, climbing over debris and suppressing sniper positions. Where German planners had assumed their bunkers and fortified houses would halt any armored advance, the Shermans find ways over, around, or through. At Hill 122, near Saint-Lô, German officers are stunned. Observers report tanks surmounting earthen mounds designed to funnel attackers into kill zones. Turrets rotate swiftly, cannon fire neutralizing positions that were considered secure. Machine guns, anti-tank obstacles, and concealed artillery fail to halt the advance. Reports from the field describe a mechanical force moving with uncanny coordination, ignoring natural and man-made barriers alike. One officer notes in his diary, "It is as if the tanks climb, not roll." The key lies in engineering innovations. The Sherman's suspension, vertical volute spring system, absorbs shocks from uneven ground and rubble. Wide tracks prevent the vehicle from sinking into mud or sand. and the combined arms approach amplifies these mechanical advantages. Engineers lay makeshift ramps, infantry suppress defensive fire, and tanks exploit gaps, maintaining constant pressure on German positions. This synergy creates a cascade effect. One position falls, and the next is vulnerable. By evening, St. Lo's defenses crumble. Streets that should have been choke points for defenders become thoroughfares for American armor. Tanks climb over rubble, enter buildings, and support infantry with continuous fire. German artillery, designed to target slower, predictable movements, struggles to engage mobile and adaptive armor. The psychological impact is profound. German soldiers, witnessing tanks overcome obstacles previously considered impregnable, question the reliability of their own fortifications. Simultaneously, further north, American forces face the hedgerows of the Bocage country. German Panzer IVs attempt counterattacks from concealed positions. Yet, Shermans equipped with extended 75mm guns and improved armor withstand hits while continuing their advance. The tank's ability to climb embankments, crush barbed wire, and cross drainage ditches undermines the German defensive doctrine, which relied on channeling attackers into kill zones. At Mortain, during the German Operation Lüttich counteroffensive in August 1944, Shermans again astonish their adversaries. Concentrated German armor and artillery are unable to halt the combined assault of U.S. tanks and mechanized infantry. Sherman crews navigate steep inclines and fortified positions that were assumed to be natural barriers. Every success reinforces the lesson. Mobility and coordinated firepower are more decisive than static fortifications. By the time the Allies break out from Normandy in late August, the cumulative effect of these actions is clear. German defensive lines, based on bunkers, obstacles, and natural terrain, have been repeatedly neutralized by armored ingenuity. Reports from German headquarters express a mixture of awe and alarm. American tanks consistently climb where they should not, bypassing defenses and rendering months of preparation futile. The turning point is not a single moment, but a sequence of operational decisions and mechanical advantages coming together. Shermans, supported by engineers, artillery, and infantry, redefine what it means to breach fortified lines. Every bunker climbed, every hedgerow overcome, demonstrates that flexibility, preparation, and ingenuity can outmatch sheer defensive investment. Across the front, Allied commanders recognize the opportunity. Armor is deployed aggressively to exploit gaps. Infantry follows swiftly. Supply lines keep pace, ensuring that the mobile advantage is sustained. German forces are forced into reactive strategies, constantly adjusting to innovations they cannot anticipate. The battlefield has become a theater of maneuver, not merely attrition. By September 1944, as the Allies push toward the German border, the operational lessons of Normandy have been internalized. Tanks no longer just support infantry, they lead, overcome obstacles, and transform defensive positions into temporary impediments rather than permanent fortresses. The Sherman's success climbing bunkers becomes a symbol of American adaptability, industrial efficiency, and tactical foresight. The broader implication is profound. Warfare is no longer determined solely by fortifications or natural terrain. Mechanized mobility, combined with innovative tactics and engineering, can redefine the parameters of engagement. The German High Command, witnessing these repeated breakthroughs, confronts a new reality. Traditional defensive doctrine must evolve or fail. By the end of the climax, the battlefield is no longer dominated by static structures, but by the strategic ingenuity of the Allies. Sherman tanks, climbing bunkers, and negotiating terrain once deemed impassable exemplify the decisive combination of technology, training, and tactical foresight that shifts the momentum irreversibly. Every bunker surmounted, every defensive line breached, sets the stage for the Allied advance into Germany itself. The invasion of Normandy and the subsequent push through France proves that innovation and coordination can overcome even the most formidable natural and man-made obstacles. This moment leads directly into the aftermath, where the consequences of these breakthroughs, strategic, psychological, and operational, begin to reshape the European theater of war. September 1944. The rubble-strewn streets of northern France bear witness to months of relentless combat. German defensive networks, once thought impenetrable, lie in ruins. Bunkers that had been carefully positioned, reinforced, and manned to hold back any advance are now empty shells, crushed or bypassed by tanks that seem to defy gravity itself. The immediate military consequences are staggering. The rapid American advance after the Normandy breakout accelerates the liberation of French towns and villages. Cities like Caen, Falaise, and Saint-Lô, long contested, now see Allied armor moving through corridors once deemed traps. Sherman tanks, climbing over embankments and through fortified points, turn what should have been a slow slog into a series of swift, operationally decisive maneuvers. German forces, exhausted and demoralized, struggled to re-establish defensive lines. Commanders report that traditional strategies relying on bunkers, hedgerows, and natural terrain are failing against an enemy capable of scaling obstacles effortlessly. Field reports describe soldiers watching tanks roll over fortifications, bypassing minefields, and neutralizing positions with combined arms support. One Panzer Division officer notes in a post-action report, "Our bunkers are no longer barriers. They are monuments to futility." The psychological impact is as decisive as the physical. German troops begin to question the reliability of their own preparations. Morale deteriorates as tanks appear in areas previously considered secure. Soldiers retreat hastily, abandoning positions they would have held for weeks. The repeated failure of defensive positions to slow the Allies breeds a sense of inevitability. American mobility, reinforced by engineering ingenuity, begins to dominate the strategic narrative. Meanwhile, the Allied side experiences a surge in operational confidence. Sherman crews report unprecedented success in traversing terrain that would have slowed or immobilized previous generations of tanks. Infantry units coordinate closely, moving in tandem with armor, knowing that obstacles no longer guarantee a halt in progress. Commanders adapt quickly, deploying tanks aggressively to exploit gaps in German lines and consolidate territorial gains. The industrial and technological implications are equally profound. The Sherman's suspension system, combined with wide tracks and improved armor, proves its value beyond initial testing. Engineers and tacticians recognize that mobility over obstacles, not just firepower, can dictate the tempo of an operation. This principle influences subsequent campaigns in the Low Countries, the Rhineland, and ultimately the push toward the Siegfried Line. Allied planners also note that American production capacity allows this mobility to be sustained. Losses of individual vehicles are quickly replaced. Maintenance units can repair damaged Shermans and return them to service, ensuring that the armored advantage remains constant. In contrast, German forces, constrained by dwindling fuel, ammunition, and industrial output, cannot recover as effectively. The imbalance in resources amplifies the battlefield consequences of every breakthrough. Strategically, the breakthrough at Normandy and the mobility of Sherman armor reshape German defensive planning. The High Command begins to acknowledge that bunkers, pillboxes, and fortified positions no longer ensure control of the battlefield. Entire doctrines, built on the assumption of impassable obstacles, are rendered obsolete. Field commanders face the reality that any fixed defensive line may be bypassed or climbed, forcing a shift toward mobile reserves and reactive deployments. The combined effect of these outcomes, territorial gains, demoralized opposition, tactical innovation, and industrial superiority, sets the stage for the final Allied drive into Germany. What had begun as the challenge of overcoming fortified bunkers in Normandy evolves into a broader lesson. Mechanized ingenuity, supported by coordination and industrial capacity, can redefine operational art. The consequences are not merely strategic. They also influence morale, planning, and the very perception of armored warfare. Sherman tanks, once standard tools of fire support, are now symbols of adaptability and inevitability. Every German soldier who witnessed them scaling a bunker or crossing a hedgerow understood that traditional defenses could no longer dictate the terms of battle. This operational and psychological transformation naturally leads into Aftermath, Section 2, where we will explore the broader consequences across the European theater, including the impact on German command decisions, civilian populations, and the long-term lessons for armored warfare. As autumn 1944 settles over Europe, the broader consequences of American armored ingenuity become increasingly clear. German commanders, long accustomed to controlling the battlefield through prepared positions, find their strategies unraveling. The psychological toll of watching Shermans scale bunkers and breach fortifications cannot be overstated. Reports from the Wehrmacht describe soldiers frozen with disbelief as American tanks appear where they were considered impossible. The familiar rhythm of defense, dig, hold, repel, no longer applies. Field intelligence from the Western Front highlights a cascading effect. German divisions assigned to delay the Allies struggle to maintain cohesion. Units tasked with holding towns find themselves bypassed or flanked, forced into rapid retreats. Supply lines are disrupted, and ammunition, food, and medical support fail to reach frontline positions in time. Commanders attempt to regroup, but the combination of Allied mobility and overwhelming air support makes sustained defensive operations nearly impossible. By October, several panzer divisions report critical shortages of fuel and operational tanks, compounding the strategic collapse. Civilian populations also experience the indirect consequences of this armored advantage. Towns that might have endured protracted sieges see shorter, more intense engagements. While destruction still occurs, the speed of the American advance reduces prolonged bombardments, sparing some infrastructure. Conversely, areas where German resistance collapses suddenly face chaotic retreats, with civilians caught between fleeing soldiers and advancing forces. Eyewitness accounts describe streets suddenly filled with armored columns, rolling over obstacles that once promised sanctuary or defense. At the strategic level, the ability of Sherman tanks to traverse bunkers and fortifications forces a reevaluation within the German High Command. Hitler and his generals, frustrated by repeated failures, begin ordering the construction of the Siegfried Line, an extensive network of fortifications along Germany's western border. Yet even here, lessons learned from Normandy and the Low Countries undermine confidence. Reports stress that unless defenses are paired with mobile reserves capable of countering the Sherman's agility, they are merely temporary barriers. The reliance on static fortifications increasingly appears inadequate against an opponent who has mastered obstacle mobility. Allied commanders, by contrast, capitalize on this tactical advantage. Operation Market Garden in September 1944, though ambitious, leverages the lessons of Sherman mobility. Bridges, embankments, and urban defenses are approached with confidence, supported by engineering units capable of clearing mines and debris swiftly. The success of armored reconnaissance and combined arms coordination stems directly from the earlier Normandy breakthroughs. American and British armored forces operate with a sense of inevitability. Obstacles are temporary, terrain is negotiable, and speed dictates initiative. The industrial ramifications of these successes further reinforce the disparity. Sherman production continues at a staggering pace, with the United States maintaining the ability to replace losses and introduce incremental improvements. German armor production, constrained by Allied bombing and resource shortages, cannot match the volume or reliability of American output. Each operational Sherman becomes a multiplier of both firepower and psychological pressure, eroding German capacity to organize effective resistance. By the end of 1944, historians note that the Normandy campaigns marked a turning point not merely because of territory gained, but because of the operational doctrine demonstrated. Sherman tanks, capable of climbing bunkers, crossing rough terrain, and supporting infantry rapidly, redefine the concept of mobility in European warfare. The symbolic weight of this capability, bunkers that no longer intimidate, obstacles that no longer dictate strategy, has lasting consequences for both the immediate conflict and post-war armored doctrine. The collapse of German expectations also accelerates Allied advances into the Rhineland and eventually into central Germany. Each bypassed defensive position reinforces the strategic truth. The side that can innovate mechanically and coordinate effectively will dictate the tempo of war. German soldiers report in post-war interviews that the sight of American tanks scaling bunkers left them bewildered, disoriented, and demoralized, capturing the deep psychological impact beyond the battlefield. With both the operational and psychological consequences laid bare, the stage is set for the reflection, where we will examine what this technological and tactical breakthrough meant for the future of armored warfare, military strategy, and the broader narrative of World War II. In the quiet aftermath of Europe's liberation, the sight of empty bunkers and shattered defensive lines tells a story that goes beyond maps and casualty reports. American tanks had not merely rolled over terrain, they had rolled over expectations. What once seemed immovable, the stone and concrete of the Siegfried Line, the reinforced bunkers along Normandy's beaches, proved negotiable in the hands of a force that understood both engineering and innovation. The German army's reliance on static defenses, cultivated over decades, was rendered obsolete not by sheer numbers, but by the mastery of mobility and mechanical ingenuity. The ability of U.S. tanks to climb fortifications reshaped the philosophy of armored warfare. Commanders no longer viewed obstacles as endpoints, but as challenges to be measured, calculated, and overcome. Mobility became strategy. Engineering became doctrine. The Sherman, often underestimated by German intelligence, emerged not only as a vehicle, but as a symbol, proof that preparation and adaptation could outmatch expectation. Beyond the battlefield, this lesson resonated with industrial and military planners worldwide. It demonstrated that technological and organizational innovation could tip the scales as decisively as manpower or firepower. American production systems, combined with tactical creativity, allowed a single design to multiply its impact across thousands of engagements. The war, in essence, had become a contest of ingenuity as much as strength. For the soldiers on the ground, the experience shaped morale and confidence. Allied troops could trust that their machines would carry them, even across terrain the enemy considered impregnable. Conversely, German soldiers confronted a psychological erosion as their carefully prepared defenses proved inadequate. A nation built on the assumption of territorial control faced the stark reality that an idea, executed with precision and scale, could transcend fortifications. In the broader sweep of history, the Normandy breakthroughs and the adaptability of U.S. armored forces signal a turning point. Power in modern warfare is no longer defined solely by possession, but by application. Machines, ideas, and coordination now define victory. Where German commanders once measured success by the strength of walls, American forces measured it by the ingenuity to climb them. The lesson endures. Empires may rise from conquest, but the future belongs to those who can innovate. In World War II, the Sherman tanks' climbing bunkers did more than breach concrete. They breached assumptions, and in that breach, they revealed the evolving nature of modern war.